My name is Hiroshi Yamamoto of Tokushima University. I'll be the chair of the first session today. And actually, I'm also the first speaker of this session. And I will start, I'm going to start my talk. I will be talking about effluent toxicity testing for management of toxic chemicals in watershed area. This session is on the wastewater monitoring and use. I'm not sure I'm the proper person to chair the session, but I will do my best. Anyway, first of all, I will start with where I'm from. Maybe you are not familiar with Tokushima. I'm from Tokushima. Tokushima is located in, actually no, not working. Maybe here. Oh no, not working. This is not working. Anyway, Tokushima is located in Shikoku Island, actually, and it's about 200 kilometers southwest of Kyoto. And yes, this is a very small town of the population of about 500,000. And actually, probably you're familiar with the typhoon. The typhoon Naka is now located down there, and that hit Shikoku Island yesterday. And actually, I had a class yesterday morning, and actually, I barely escaped from Shikoku to get here yesterday. And I took the highway bus to take over the suspension bridge, and that's one of the good sightseeing points there. And also the Tokushima is famous for the Awa Dance Festival that's held in mid-August. Actually, Tokushima is not Fukushima, it's a far area, it's a different place. Anyway, I will start my talk. And how many chemicals are existing in the world? Maybe 1,000 millions. Yes, there's a hint at the bottom, and one of the answers is 100 million. That's the number registered in Chemical Abstract Service of American Chemical Society. And actually, the number of chemicals actually used or manufactured in industries are about 100,000. That's probably the good answer. And among those, only 5,000 are produced over 1,000 tons per year in OECD countries. And also the problem is the number of chemicals with the persistency, accumulation, toxicity data are very, very limited. Is that working? Anyway, that's okay. And approximately only the 5,000 chemicals, the toxicity data are available. So there are a huge missing link in current regulation on toxic chemicals in Japan. Now the current regulation of industrial municipal wastewater in Japan are based only on individual chemicals. And for the regulation, basically we use we do have a discharge limit for 27 items at the right bottom corner. There are only 27 chemicals, including the heavy metals like mercury, cadmium, those kind of stuff. And also there are another regulation on the BODs and those kind of things, including zinc and nonylphenol, but the total is only 42. And also there are voluntary-based chemical management based on PLTL that covers 462 chemicals. Those numbers are far below the numbers used in the world, like 100,000. So the number of chemicals are now increasing, so that the number of the cost of monitoring is also increasing. So the effects of unknown chemicals are also the concern, and also the mixture effects of those kind of compounds are also the main unknown. The upstream regulation in Japan, we call it CSCL, that started to require ecotox data in 2003. So why not for the effluent and also the receiving water body to use the ecotox data? Actually, some other countries are already use those kind of things to regulate the wastewater and the receiving water body. What's the CSCL? CSCL is the acronym of Chemical Substances Control Law, and that was enacted in 1973 after the mass poisoning occurred in late 1960s in Japan by PCBs. And this is, I believe that this is the first law in the world to require new chemical substances with over 1 ton per year production for various property data, including persistency, bioaccumulation, and toxicity. And the recent amendment in 2003 requires data for ecotoxicity, such as acute toxicity for fish, Daphnia, and algae. Actually, this CSCL is equivalent to the regulations like LEACH in the EU and also the TSCA in the US. What is important, what is necessary to properly manage the toxic chemicals in water environment? Actually, we need 3 approaches. One is the individual chemicals, the chemical analysis. And another is on-site biomonitoring. So that's like checking some of the invertebrates, taxa, and those kind of things in the on-site. The other thing that is important is to do the toxicity test. The 4F, we call it 4F toxicity test, bioassays, to understand the toxicity and understand the effects of unknown substances. What about outside of Japan? There are many countries, they regulate the wastewater using the bioassays. For example, in North America, in the US, they use WET, Wall Effluent Toxicity System, implemented in 1995 using acute and subchronic or chronic toxicity tests using algae, Daphnia, and fish. And in Canada, they implemented the environmental effect monitoring. They use all 3 approaches I just showed you before in the last slide. And that is applied for the paper mill and steel manufacturing factories. And in Europe, in Germany, they use acute toxicity tests using the Daphnia, fish, and other things to charge tax under the Wastewater Control Act. And in France, similarly, they charge tax based on the Daphnia acute toxicity test. And in some other countries like Spain and Sweden and other countries, they also use bioassay to regulate the effluent and receiving water body. In Asia, South Korea implemented a system in 2011 using acute toxicity tests for Daphnia. And in Taiwan, also has recently implemented the system. What about in Japan? In Japan, actually, we are kind of struggling right now. We started discussion in 2009. Actually, I'm a member of the board, and still we are discussing because the industries are opposed to this kind of system because they don't like to pay more. So we have the regular regulation based on the individual chemicals. Why not? Why do we need the other things? So that's a huge problem right now. But we already developed a method for the effluent management using the algae, Daphnia, and fish. For the algae, we use basically the OECD test criteria 201 using green algae to find out the growth inhibition ratio. And for the middle, we use Daphnia. We use Daphnia livia instead of Daphnia magna. We usually use for the chemical management and wastewater or effluent management in other countries. That is usually used in our Canada and US, but it takes shorter time, like about 8 days to do the chronic toxicity test. And for the right one, the fish, we use zebrafish, giant radio. That's a zebrafish usually used in European countries. And we use actually embryos and larvae to point out the effects on hatching ratio and mortality. And it's a kind of the subchronic toxicity. We apply this methods to the river waters all over Japan, from Hokkaido to Kyushu. As you can see that you can see the snow in the top picture, and that's Hokkaido in winter, and we took samples there, and also we took samples in Kyushu and all over Japan. We took the total of 30 samples all over Japan. And these are some of the examples, and the dark blue diamonds are the hatching ratio, and light blue triangles are the mortality. For the left one, you can see that the slight effects on the mortality at the highest concentration, 100% of river water. And for the middle one, you can see that the decrease in the hatching ratio at the higher concentration of river water. And for the right one, you can see the effects on mortality even in the lowest concentration, 25% of river water. For the Daphnia, the orange bar shows the number of neonates that the reproduction, and usually in control, they deliver like 16, 17 neonates in 8 days. But in the left one, as you can see that even in the lowest concentration, all the Daphnia died in that river water. And also in the middle one, you can see that there's inhibition of reproduction even in the 25% of river water. And for the right one, you can see the effects of mortality at the highest, only in the highest concentration of river water of 100%. And for the algae, those are the growth inhibition ratio. And as you can see, the left one, there's no inhibition, but the middle one, you can see the significant, statistically significant inhibition, even in 25% of the river water. And for the right one, you can see the growth inhibition in 50% and 95% of the river water. And this is the summary for the 30 class A rivers. In Japan, they call it class A river, but this is what that means the rivers, the major rivers governed by the national governments. And as you can see that those samples surrounded by the red box, those are the samples we detected toxicity. The total is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 out of 30 samples, we found toxicity for at least one organism. We actually applied that to the urban streams, very affected by the household domestic wastewater, and we found that about 60 to 70% of samples were found to be toxic to at least one species. And we applied that to watershed area, and we applied that to Yoshino River watershed area in Shikoku, Tokushima. And we selected 5 sampling points, and the Tokushima city is, the Tokushima University is located in the river mouth, the right of that figure. And yes, we selected 5 samples, and we also checked the seasonal variation for the Takase bridge, and we sampled every month, and we checked the toxicity and also the water quality of the water samples. And we also applied that to Yodo River watershed area near Kyoto and Osaka. And in Katsura River, the place the river receives the effluent or wastewater treatment plant from Kyoto City, and also some sampling points near Osaka, and also the industrial area, and that that received also the Effluent of Wastewater treatment grant. This is the items we measured for the sampling, and you are the water quality guys, so you are familiar with this things, and we measure the pH, DO, and the EC on site, and we also measure the ammonium nitrogen, COD, BOD, and hardness in the laboratory. This is the results for the seasonal variation. As you can see that if it is those figures are based on the TU. TU is a toxicity unit that's inverse of NOAC. So if it is over 1, it means that toxic. And you can see that about 30% of the samples are toxic, and there's some seasonal variation, especially in spring and summer. We found toxicity mostly to algae and Daphnia. And we also checked the spatial variation in Yoshino River watershed and also in Yodo River watershed, and we found some toxicity in some of the river water samples. Finally, we did the principal component analysis based on all the toxicity data and water quality data, and you can find that the right side, you see that the principal component 1 is very high for all the water, most of the water quality data like COD, BOD, ammonium, and electric conductivity and hardness. And DO is of course in the opposite side, and strangely, for the Daphnia toxicity, it's very specific, and principal component 2 is very high for these compounds. So that means that the Daphnia toxicity is very specific and irrelevant to the water quality. So that there are some factors that affect the other factors, like I'm not sure it's heavy metals or like insecticides that might affect the Daphnia toxicity. Okay, here's a summary. Approximately 30% of water samples collected in classic rivers and 60% from effluent and other streams were found to be toxic to at least one organism. And also the wet type ecotoxicity testing will provide direct information about the risk of river water exerted by toxic chemicals. And since the number of chemicals is increasing, the system is monitoring both the individual chemicals and toxicity. That's important, and especially for the unregulated, to monitor the unregulated or unknown toxic compounds. For the suggestion future works, yes, further investigation is of course necessary to characterize the toxicants of concern and possible toxicity identification, evaluation, with using the chemical analysis, using LCM, SMS, or like ICP-MS. This system can be applied to those countries with no proper regulations or no good instruments, because you can use the aquatic organisms to monitor the toxicity of the water samples. That might be much cheaper. And also, we are currently working on some projects under the Asian Core Program in Malaysia to better manage the risk of toxic chemicals in the unit of watershed area. Okay, finally, I acknowledge the collaborators, students, and the funding, and I'll conclude this talk. Okay, I'll now take some questions. Any questions? Okay, right.
Thank you very much. It's a very interesting presentation. How many chemicals are regulated by the Japanese law, and if in industry discharges chemicals that are not regulated, what are their discharge permits?
Actually, in Japan, we do have 27 items, as you can see, that the 27 chemicals, and 15 items, including BOD, COD, and also some of the chemicals that affect the aquatic organisms. And also, as I showed you, the PLTR, that's a voluntary based chemical management. You need to register how many chemicals you use every year. to the government, and then we collect those data and then publicize over the internet. So yeah, those are the current regulation. And also there's another regulation for the new chemicals and the existing chemicals with high risk. We do have the CSCL. We check the lists of each chemicals registered in CSCL. I think it's about 20,000 chemicals are now registered in CSCL. So we check all the lists of all those chemicals, and if that depends, we can categorize those chemicals into each category, and if it is in designated chemicals, there's some regulation. You need to do some regulation, and also we do some monitoring of those kind of chemicals. But that's not compulsory. That is for voluntary base. Right.
Well, thank you very much for providing us with insight on the wet. Just picking up from one of your slides, the last one, where you are saying that the recommendation that we're putting forward is for the countries that they don't have regulation to use bioassay. And I see that currently you are doing a project in Asia, Asia Core Program. What are the plans to do it in Africa? Do you have any plans?
Yes, sure. If I got funding, yeah, that might be the possibility, because for some of the simplified systems, bioassay, like as I showed, microtox, that might be very easy, much cheaper than the buying some of the instruments like HCMS, MS, and HPMS to monitor all the chemical compound, toxic chemicals in river water. So yeah, that might be the option. We are now thinking about that option, yeah, doing those kind of works in Africa also, yeah. Actually, one of my collaborators are doing, one of my colleagues actually is working to monitor all the micropollutants in Africa, but he's kind of suffering, there are so many micropollutants and also the concentration is very high, but not sure about the effects. Because the individual chemical, it's okay, but not sure about the mixture. And there are several kinds of micropollutants, including heavy metals, pesticides, and surfactants, all those things.
But where exactly in Africa?
I'm not sure right now. Sorry. If you have some proposal, yeah, I will do that. And we are not thinking about that right now. All right, thank you. All right.
Thank you, Professor Yamamoto. That was very interesting for me because of being many years in bioassays. The method is very interesting. And are these methods now on the internet?
Actually, the methods, the Japanese methods are now in the stage of draft right now. Actually available on the internet, but it's in Japanese. So I'll send you if you.
Thank you.
And actually the methods, all the methods are, I think, mostly very similar to the one you use in the US EPA actually. So you can access to the US EPA site, and that's very close. So our methods are very close. Maybe. But we use zebrafish. They use pattern, but they're basically the same.
Maybe I can get the method from you also. And what type of bioassays exactly used for this toxicity testing? What type? It means quantum bioassays. What type of bioassays you use? Is that for mixtures, as you told me?
Yeah, actually, we kind of directly expose the organisms to the river water, and then diluted it, and also we measure the.
What is the final analysis method?
Final analysis. You are talking about the endpoints.
Yeah.
Okay. Observations.
Yeah. We use always probate. I use most probate, but I want to know really what was the final and criteria.
Oh, criteria. Actually, we are now discussing right now, and in Japan, we are now thinking. I'm a member of the board, so I cannot say exactly, but now we are thinking that, we are still in discussion, but we are thinking that the regulation will be on the effluents of industrial factories and also municipal wastewater treatment plants, but that is about TU, toxicity unit of 10. So that means that 10% of the water is okay. If it is okay, it's okay. Because the wastewater or the effluents are diluted if it is released into the water environment.
Not based on the LC50 or not?
Actually, that's based on the NOAC. NOAC, we are going to use NOAC. I'm not sure we should use NOAC or not, because in European countries or in OECD, they don't like NOAC, right? But US and Japan, they like NOAC, because no effect concentration, I'm not sure there's no effect concentration, but that's statistics, so I'm not sure. But I prefer to use EC10 or EC50, but they like to use NOAC. And then they use NOAC to calculate the TU, toxicity unit, and then find out the toxicity unit should be less than something, like 10 or like that.
Thank you very much. Maybe
All right.
I can get the method from you then.
All right, sure.
Thanks.